Good morning, everybody. All right, we've got some interesting stuff on the bench today. These are VGT, so variable geometry turbo controllers for Toyota Hiluxes. I'm sure a lot of people would have seen them. 06 Hilux, that's what that looks like. We've got three of them. They're all been nuked. They're all slightly different. So there is one, oh, sorry, these two are the same, but this one is a different part number, and I believe this was the original one. These are, as far as I can tell, direct replacements for the original one. So all the components are different, obviously, but they do the same thing, pin outs are the same, etc. Now, what we've got is this has had a turbo fitted, and it's had three controllers fitted afterwards, and we've got an issue where they keep dying consistently. So if we go under the microscope, right, you can see we've got a blown transistor there. So it's an A1244 transistor, which is, where's the data sheet? It is a PNP transistor. It's got a 50 volt usage range with a 5 amp application. So what we've done here and what we're trying to do here is we're trying to chase this back for this customer. Alright, so you're going to have to bear with us on this one because I want to explain this fully. It's turned out to be pretty interesting. So we've got three dead turbo controllers for this particular vehicle, 06, 07, 8 Hilux, something like that. Starting with original number one, right, as we can see, blown transistor. So trying to figure out what that transistor feeds. We'll put this down and I'll just show you. So multimeter in continuity mode, we've got pin 1 and pin 6 is basically fed by this transistor. It's not our power feeds to the unit because I've checked that. Our power feeds come on pin 3, which is over here somewhere, over this side, and our ground is these two here. So they're our grounds, and our power feeds pin 3. So 1 and 6, main problem. Now, as for what's caused the high current through 1 and 6, we'll start with figuring out what this is, what controls it, and what it feeds. So what we've got, right, on this side, we've got this capacitor here. Now this is a 47 UF cap that then feeds this transistor, which then feeds 1 and 6, or gets controlled 1 and 6. So this driver here, if we try and, I might go under the microscope for this, next to that blown transistor we've got a driver. So we can see that that driver here is pinned out, and if we flip it, it goes through the board, goes back and goes to that driver. So that driver chip controls that IC there, controls that transistor. So if we have a look, basic functions of how a transistor works. Transistors are composed of three parts: a base collector and an emitter. The base is the gate controller device for the larger supply. So think of it as though it's a relay, right? Automotive terms, gets switched on by this driver through the base circuit. The collector is the larger supply, so the collector is the feed, and then the emitter is the output. So what we essentially have here is a driver chip controlling a transistor that outputs to pin 1 and 6. So if we chase it back through the board. Now, as far as what has caused it, a customer who's an auto elec has supplied all the diagrams and everything that they've used for testing. They have tested all this, so I'm assuming it's an intermittent issue, an intermittent short. This pin 1 and pin 6 goes down to the vane position sensor. So you've got a 6-wire sensor down here, and I'm assuming that it is a switched feed for that vane position sensor, and either this position sensor is internally shorting, or these wires are shorting somewhere in between. So that is the next thing that the customer is going to have to check. Now, from there, we're going to repair these three units. So that's number one. If I show you number 2, same thing, right? We'll go under the scope, and you can see massive current draw through there. And then if we go, I don't want to get these mixed up, number 3 actually isn't too bad. Where are we? But there is a little bit of discoloration on the top of it. So we're going to get those 2 units repaired. We're going to replace those transistors and see what happens from there, because it's an interesting issue. I'm confident and I'm certain that something outside of this module is causing this. If we go on our main power feed and ground on this unit, right, so if I hook up to board ground, that's our ground there, ground pins are good. If we go on the main power feed, we don't have a dead short. What was the other one? The other power feed I think was number 3, which is an ignition feed. Where are we? Number 3. Where's number 3? Bear with me 2 seconds. 3 is that one there, so it's that top one. So it should be this one is our ignition feed. We've got no short on that ignition feed, and we've got no short on the main power feed. So that's good. Also, obviously, if we go over like our main caps and things like that, we've got no dead short on any of those caps. So this is going to need a new transistor, and it's going to need whatever external to this on those 2 pins is drawing too much current rectified. To give you an idea of how much current it would take to nuke one of these transistors, I've got the data sheet printed out. So these are a 50 volt IC with 5 amp rating, so obviously they're pretty capable of handling current. It's going to have to be a pretty decent short circuit through that wire to actually kill that particular transistor. So we're going to get these parts ordered, we're going to get these 3 modules fixed up, and then the customer is going to rectify whatever's causing that and go from there.